This is Pre-Calculus Concept 38C. We're going to look at the concept of limits this time, thinking about them graphically. So we're going to do a few examples and then a few tries for you at the end. So I'm looking at a function this time. Instead of giving you an equation, I'm just going to give you a picture to look at. And down here, we're going to try to figure out the limit as x approaches 5 of this function. So you might notice something unusual going on at 5. There's a hole in the graph. There are certain functions where you'll have a hole like that. But remember, the whole idea of a limit is it doesn't matter at all what's happening at 5. It's only what's happening near 5. So in the same way we looked at our table, we want to kind of just think about points that are closer and closer and closer to the 5 point and what the y values are doing. Or if I move from this direction, if I get closer and closer and closer. So hopefully you can kind of see from the scale that I'm getting closer and closer and closer to that y value, which is 6. So the answer to this limit is 6. And notice that f of 5 does not exist. But that doesn't matter at all in this problem because the limit is only the behavior near 5. All right, this is another example. It's pretty typical of limit questions, and that is when you have a piecewise function. So this is a piecewise function, two different pieces of a graph that may or may not come together. The answer to this question, what is the limit as x approaches 1, is different depending on whether you're coming in from the left or coming in from the right. Because of that, we say that the limit does not exist. DNE is a good way to abbreviate that. However, you can do what are called one-sided limits. So let's look at the notation for that. If I said, what is the limit as x approaches 1, with a little minus sign right there, that minus sign means from the left. All right, and so what I'm going to do is go back to my picture, look only from the left side, so this piece right here. And as I get closer and closer and closer, think about what y is getting closer and closer to. The open circle there doesn't mean anything. It just means you're getting closer and closer to it. And so hopefully you see that there is a left-sided limit, and that answer is 7. Right? You can also do limits from the right-hand side. So the limit as x approaches 1, when you have a little plus like this, means a right-sided limit. And now I want to be looking at the graph near 1, but to the right of 1. So now I'm looking at this behavior. And you can see it's getting closer and closer to 3. In fact, it's the 3 all the time, but 3 is the answer to that. Okay, so this is a problem that has a left-sided limit. It has a right-sided limit, but the limit at 1 doesn't exist. So in order for the limit to exist, both sides have to behave the same. All right, we got 3 U-tries for you to consider. They're listed here on the left. We're going to ask you one at a time. I will give you a hint that one of these is a does not exist, and the other 2 do exist. All right, do your best to answer these 3 U-tries. All right, quick explanation. If you look at the values near -3, we're talking about the behavior on either side of -3, and you can see that that's getting closer and closer to 9. Does not matter that there's an open circle there. It's the behavior near -3. When I look over here at 4, the behavior from the left and the behavior from the right is different. That one is your does not exist answer. And finally, the limit as x approaches 4 from the right means the behavior on the right side of 4, and that value is 6. You're getting closer and closer to 6. In fact, you're staying at 6. All right, this gets a little tricky with the right side, left side. Be sure to ask questions if you didn't understand these in class, but hopefully you get the idea of analyzing limits graphically.